Hello, everybody. It's 9 a.m. sharp in most of Europe, and it's time to start our HTEC Days session for today. Welcome to everybody, depending on where you are across the globe. Good evening, good morning, and thank you for joining us today. HTEC Days is an initiative we started 3 years ago now. It was mid-COVID, and it was an opportunity for us to get together, to share our knowledge internally, to get to know each other, and to discuss some important topics. And this year, for the first time, we are opening up our HTEC Day sessions to the public today. And we have prepared 10 super exciting presentations, panel discussions for you, ranging from deep tech conversations to talking about product design and different business topics. For those of you who don't know us so well, HTEC Group is a digital product development and engineering services company, and we're working with some of the world's leading companies on developing their digital products and solving their toughest engineering challenges. We are a team of more than 2,000 experts in engineering, product design, and business, operating across 12 different countries. So without further ado, thank you for joining us today. You can visit our website, htecgroup.com, to see the full agenda for what we have prepared for the day, and feel free to invite your friends and colleagues and anybody who might be interested to join us throughout the day. I think we've prepared a little bit for everybody, so hopefully there is a topic in there that will catch your attention and that will be together throughout the day. I want to introduce now our first moderator for today, Irhad, who is joining us from Sarajevo and who will announce our first speaker and moderate the first session. Irhad, please kick it off.
Thank you, Katja. Good morning, everyone. Good day. My name is Irhad Babic, and I will be moderating this next topic we're about to engage. And it is my real and great pleasure and privilege to announce my dear colleague, Jasmin Azemovic, who has served as Mistral's Chief Information Officer for some time now, and who has joined HTEC recently through our strategic partnerships and acquisitions. And he's also a beloved university professor, Microsoft MVP, and a former dean at Jamal Biedic University in Mostar. He will be telling us today about SQL Server 2022 applied cryptography. And in my experience, security-related topics usually get a lot of attention and interest. So before we begin, I must just ask you all to send us your questions through the Q&A box on your screens, on the bottom of your screens. And we will make sure we spare some time at the end of the lecture to cover as much of them as we can. Now I would like to ask Jasmin to lead us in and share some of his knowledge and experience regarding the SQL Server 2022 applied cryptography. Sorry, Jasmin, please take it away.
Thank you, Irhad. Thank you, everybody. Good morning. And just before I start, just can you confirm me that you see my additional slide on the screen?
Yes, we can.
Okay, great. Thank you very much. So there is no better way to start the day with some hardcore topic from technical perspective. I believe cryptography is kind of dry, but I believe I will try my best to make it interesting for all of those of you who have experience and also who does not. So I will try to explain to you why it's important and what is the last line of defense that actually stands after the data breach to actually minimize the consequences of the breach if something goes wrong. So the cryptography is only way to actually minimize or mitigate that stuff. So I will try to briefly lead you in about just initial stuff. But before I start, actually, just little note. The title is a new version of SQL Server, but to be honest with you, there is no big difference from version let's say 2014 and 2032 in terms of cryptography. Only it's improved and made better. But as on the feature set, almost everything stays same. Okay, thank you. So the topic is actually divided in two sections. I always in these cybersecurity topics, I'll always try to actually make you aware before the start. So a couple of the initial slide is just to wake you up, to shake you, to actually show you what if something goes wrong, what are the consequences on your business, on your company, if something goes wrong. And the other part of the presentation is actually about technical topic itself. Okay, the Irk had already mentioned about me, so there is no need to actually to explain anything more about me. He says more than enough. Okay, so when actually breach is happened, the breach is happened when threat actor, malicious users, inside the threat or outside threat, so it doesn't matter. So we are not speaking about the person or entity, is actually get in possession of your data, of your intellectual property. In most cases, the malicious actor, they always will try to get the gold, and the gold is the data. When I say data, yes, it can be documents, Excel sheets, Word files, PowerPoint slide decks, confidential stuff. But from the customer perspective and from the business perspective, the database itself is gold, because it contains the crucial data about your customers, your business, maybe some financial data, maybe some credit card data, and all other spectrum of the information that can be misused from the third party against you and against your customer. So the part of the process of creating the software, if I may say so, that actually deals with this sensitive data and protecting database itself is crucial. And to be honest with you, unfortunately, in most companies, and not our company, in most companies, the people simply put this aside, because the focus is always to deliver, to make it works. So let's make it work. Let's do some security, some information protection, but the devil is in the details. So this presentation is actually will lead you into the details. If you skip them, then situation can be really bad. Okay, let's lead you in couple of examples when actually things goes wrong, very wrong. So the first example is a Marriott Hotel exposed data issues, breaches, and so far as I know, the Marriott Hotel in last 5 years has 2-time breach. And that's amazing. So you have the breach, you mitigate all the stuff, you say I'm fixed all this issue, and a couple of years later you have the even worse situation. So I believe most of us is actually once in a time in a lifetime, maybe it will has sleeping, it will sleep in Marriott chain of hotels around the world. So during the stay, you will probably save your information like last name, first name, your room service, credit card numbers, additional personal details that actually hotel collect itself, because it's nature of the business. But in this case, almost not almost estimation, but I believe the number is even bigger. So the 500 million of customer is actually was leaked inside the dark web. Just before I continue, there's a difference between deep and dark web. So dark web, that ugly part, that worst part, is actually part of the deep web, but deep web itself is actually not so bad at all. So it's actually it's used to communicate with the people where is oppression, or there's actually there is not allowed the freedom of the speech. Next, and now this is epic. So it's kind of old, I believe 7 or 8 years old, but it's an example. So on the scale of the epicness from 1 to 10, this is 15. I will explain why. So actually, Madison was, so past tense, was a site. Once upon a time was a site. So it's actually, I will not now speak about ethical or moral dimensions of this story. So I will leave that up to you. But this was the cheating site. So actually, the site where the people who do that stuff is actually can meet each other, or can actually make that contact in digital or physical world, and that's okay. So it's up to the person. But There's a catch. There's actually this is a screenshot from the original web page, and if you actually see the footer, you will see trusted security awards, SSL secure, discrete service. So a lot of security badges that actually has to actually say to you, we are cool, we are secure, we are safe. Come on and use our service. Actually, people buy that, and there's almost 40 million anonymous codes users inside this database. So the threat actor is actually on the summer of the breach here, actually find the weak spot, actually penetrating system, and notified the Azure Medicine management. We have your database. Please say to your customer that you lie to them. When they say lie to them, it means that actually Azure Medicine is offered the feature that customer user can delete his or her profile. So delete, and that service has charged, I believe, $10 was paid to actually delete your profile, your messages, your photos, all your discrete stuff inside this system. But actually, I believe that all who actually deal with databases, that delete in most cases is just a Boolean flag, true, false, visible not, or visible true. So actually it will hide that record from the upper layers of the application, actually will not show to the end users. So they said then please announce that, and we will not leak this data. They didn't do that. So in the autumn that year, that breach was announced publicly, and the entire MySQL database was in dark and deep web. So it's exponentially copied around the world. So even now, I believe if you're persistent, you can find it still online, and you can find the last name, first names, and all those personal details about this customer. So this is only technical stuff. So business is failed, lawsuits, and so Azure Medicine company does not exist anymore. But there's a credit behind about hundreds of millions paid lawsuit to the customers. But also there's a one dimension of this data breach. So information was not protected. So the information, the last name, first name, passwords, credit card numbers, was in the clear text. That's the point. So there was not any crypto feature implemented even on the application layer or down way below on the database level. So the final epilogue was suicides, divorce, and other stuff that actually not so good. Again, epic scale. This database was actually also found in the dark web. Is actually the entire population of Turkish citizenship. So all of them from that point in time. So I believe it's almost 50 million of people, and you see what kind of attributes is actually leaked outside of safe and secure environment. And all this data, some of them should be encrypted, but they are not. So there was in clear text. So the whole point of these examples is that important part of the database was not protected on the correct manner. So they was left on the clear text level with the mindset it's okay, nobody will attack us, or we are simply not interested to anybody, but that philosophy is not so well. Okay, and last one on this intro part, my favorite slide on any cybersecurity lecture actually I deliver is this one. So you can easily find it online. Just type "informations are beautiful," the world's biggest data breach and hacks. So just type that, and you will get from time to actually type it the most current examples of the large, not small, the large data breaches. So is that these are not only incidents, these are the breaches. So that the information and or databases was actually put outside their native entity or environment. So if you see these names, Facebook a couple of times, Pakistan mobile operator, Oxidata, Twitter, Marriott International Hotel. So there's down below a couple of times also Marriott, and there's also winner Yahoo 2 times by 1 billion. So actually it's 2 billion of customer records from Yahoo, and that's why Yahoo simply does not stand anywhere in IT business, as far as I know from my perspective. T-Mobile, actually, T-Mobile was breached, I believe, 3 or 4 times in the last 5 years. And also, there's a recent breach for 2 days. Just type in T-Mobile recent breach, and you will see, I believe, 30 millions of user records. So I don't know what's wrong with T-Mobile, but T-Mobile has serious security issues. So all these companies has and have the budget of cybersecurity measures in millions. The cybersecurity team probably is 100 and more, depending on the scale, but it happens. So it's not about the money, it's not about the budget, it's not about the scale, it's about the mindset. So each time when business goes way above of security, this will happen. So security and business should be side by side. So on equilibrium. Why? Because if security goes up, it will become the blocker, and so that's not the point. If business goes up, it will become security risk. So equilibrium should be somewhere in the middle. Sometimes security a little bit up, business a little bit up, but that's it. If everything go extreme in that situation, things will not end so well. So see, this number of records breached was measured by millions. So it's large. Okay, and now back to my favorite SQL Server, because beside cybersecurity and information security for last, I can say, 20 years, I'm actually working with SQL Server as a data platform from version 2000, I believe, yes, 2000. And for version 2005, SQL Server has actually become decent companion to Oracle and other large database vendors. But that's not the point. The point is, so these are the statistics from NIST. So these numbers are not mine. So I actually took them and actually they make this graph. So there is no input for last 2 or 3 years, but on the year 2019 from 2010, so it's actually almost 20 years. These are the numbers of the security vulnerabilities actually found on the aggregate way, so cumulative way, in this most major database vendor. So you see, SQL Server is almost 0. Okay, let's say I'm not sure, maybe 10 to 15 in last 20 years. MySQL goes sky high. Oracle also goes sky high. IBM DB2 is actually somewhere left behind, but stands well. PostgreSQL also stands well, and SAP HANA is actually stands well. But the point is that SQL Server is best. So if you have the money and opportunity to decide, and your customer wants the decent solution in time and in matter of the information protection, SQL Server is the best option. If you are speaking about open source versions and that part of development, PostgreSQL is certainly the best solution. So also my favorite one is SQL Server and PostgreSQL. Okay, now back to the topic. So apply cryptography. As I say on the beginning, cryptography is kind of dry. It's a math. So I will not go inside those details. I will try to make it on the middle and high level, but just enough to explain you why cryptography is only way actually that's a stand between catastrophe and your business and your data. Okay. SQL Server has actually and have, if I may say so, one of the best hierarchy of the encryption elements inside the environments. So it's a native. It's not plugged in. It's not third party as it is in other databases. So it's actually is a built-in inside the database engine. So it's hard coded. So it's part of the system. So there is no any additional overhead if you are using something additional inside your production environment. So this presentation is actually divided in two sections. I will explain how actually cryptography works inside SQL Server. Then after that, I will speak about two segments: pre-breach cryptography and post-breach. Actually, what's the point? The point it is that there's a feature that you can use to actually protect your data before the breach. But with additional features, you can protect your data after the breach. So if you implement them in the correct way, your database, my database, our databases will be simply unusable to third party as actually technology stands at this point. Yes, we can speak about quantum computing. There's actually nice internal session yesterday, but the quantum computing is still out of the global reach, and the breaking of the RSA 2048 algorithm is still in the theory. So it's actually still not proved in the practice. But again, American NIST is actually make a statement that in next 5 years, each business should move. I would say must. They say should. I say must. Must move from 2000 up to 4096 key length RSA encryption, because it still can be not penetrated even on theory level through the quantum computing. But also there's a bright side. There's a bright side of that story. So there's a sun on the horizon. So there's the end of the tunnel. There's also quantum cryptography. So actually, it will solve these quantum computing security risk issues. Okay. So here's one scheme of actually how the encryption is implemented inside the SQL Server. So you have three layers: operating system, SQL Server itself, and database level. So after you install SQL Server on-prem or in cloud, so it doesn't matter. So Windows Data Protection API will generate AES 256 service master key, and it will be kept on the operating system level, encrypted. So Windows API will guard that key, or Azure API if you are speaking about cloud. So Windows is also up there. After that, when you create your custom databases, each one of them, if you want to implement encryption mechanisms inside of them, will generate their own encryption keys. But here's the catch: those encryption keys will be guarded with service master key. So there's a vertical line. So SM key will encrypt DM key, database master key. Again, we are going now below. So on the database level, tables, columns, records, and views, procedures, and other database objects. If you want to protect those objects and the records, you can again create additional key, symmetric, asymmetric certificate, and so on, to actually even you can actually create the key for each separate column inside your database, but it will be overhead, but you can do that. So in a nutshell, you have three layers at least. You can have more, but three layers at least. So in theory and practice, if you somehow pulls out my cool database with my customers outside SQL Server environment, cloud on-prem, you will pull only that database with database master key, but you can't, it is impossible, pull the SM key. So the missing chain is SM key that you actually need to decipher DM key to actually decipher other keys below and to actually decipher records way down below inside your database. So it's a vertical line. So if you just pull one item out, that item can actually, it will not work. It will be not functional without other elements in that vertical line. So that's why SQL Server currently has the best crypto features on the market, period. Prove me wrong. So in terms of the encryption algorithms, we are speaking about symmetric and asymmetric key encryption. Quick intro for those public that actually doesn't know what it means. Symmetric means that you will use one same key for the encryption and decryption. So in theory, both parties in the communication channel will have same key to encrypt and decrypt, to cipher and or decipher. And it's a most common way in cryptography. But as additional protection, there is no way to actually provide a secure channel to give to other party your encryption key. There is another approach. It's called asymmetric key encryption. It means it will use two keys, public and private. Public key is used to encrypt, and you can actually put your public key anywhere online. So if you are speaking on that level, email, PGP, OpenPGP, and other actual tools that you can use to send encrypted email on asymmetric key encryption, you will give your public key freely. So if you need to send me the encrypted email only to me, you will need my public key. But here's the catch: to open that mail, I will need my private key. And private key is actually kept on my side. I should care about my private key. So it's the same here, but it's a different approach. So in SQL Server, there is no need to give the key to other party. So in this way, asymmetric key will be used to actually put additional layer of the encryption inside your data where the information are highly sensitive. So I believe that almost of you here are somewhere in IT business, and you know that sometimes information can be really classified. So on the AES, on the symmetric encryption, on SQL Server you can use AES from 256 up till 128, and there's a triple DES algorithm, but is actually here only for legacy support. So I believe in this version is turned off. So the version before I use this algorithm for legacy support, but triple DES, and so DES was brought down in 1997 or 8. Forget me if I forget the correct year. And triple DES was actually was supplement, but triple DES was actually never have the confidence of the user because DES unfamous destiny. But AES is whole different story. So if you need to use AES, I strongly advise AES 256 because it's currently best military strength on the market inside this layer. And asymmetric, it's using RSA. So unfortunately, there is no 4096 encryption, but 2000 currently is enough. But if we are speaking about this NIST advisory and I say must stuff in the next 5 years, So I believe the 4096 will quickly be shown up inside SQL Server. So it's actually here how it looks like when you encrypt with symmetric key, for example, first name. So those data in this format are visible to all of you, to all of us who actually will type a self statement on that level, or application level where you actually pull your data without decryption. So if someone stole your database, the column encrypted this way, last name, first name, credit card number, and so on, will be in this format, IS256. So simply unusable to them in current state of technology. I'm not saying about next 5 years, but currently this information can be broken if you use now the strength of the key actually depends on the passwords on physical devices, but that's a whole another story. Now there's also one tricky part. Don't ever forget insider threat, because sometimes rogue employees, spies, paid people who actually will came inside the company to actually spy on you. So that's a real scenario, people. Simply intention of all of us are not the same. So you never forget insider threat. So on the database level, admin DBA have and has full access to your data. So he have access to the keys. So and on the end of the line, DBA against all this encryption can simply just pull the key, use that key, and decipher that sensitive data. But DBA, if you are looking from an ISO perspective, SOC 2, HIPAA, and so on, should not see those data. So before a couple of versions SQL Server and all other databases doesn't have any decent solution for that. So, but always was actually customization on the application level and the database layer. But from version 2017 SQL Server and now up till 2022, there's a really cool feature. It calls always encrypted. What it means? So data itself are protected, encrypted inside the database. That's okay. That's cool. On-prem, on cloud, hybrid, doesn't matter. But decryption key and encryption key are on the client level. So, but I'll explain. There's also obstacles in this scenario. So, for example, you type subject name from customer where serial number is equal to some parameter. Parameter is 1 up to 333. Okay. Now, because on the database level, this string is encrypted. So when this query goes outside trusted boundary, so the client environment, that can be one machine, that can be the cluster, name it. So you define your trusted boundary. ADO.NET will actually have the key, and it will encrypt this query string with this parameter. So when this SQL statement goes outside trusted boundary, it looks something like this. Select name for customer where SSN looks like equal to something ciphertext. So now this ciphertext is inside database. So it will retrieve encrypted data. Now data itself will go again to the secure channel, to the customer, to something. Then we'll go through the ADO.NET where there's a decryption key. So it will decrypt this parameter, and you will see that result set, for example, it's Wayne Jefferson. So the whole point is that DBA or DB administrator or someone with high level permission on SQL Server will never have access to the keys, even if they are DBA. But here's the catch. Always encrypted can implement two ways of encryption: randomized and deterministic. So randomized means that each time encryption of the string, of the same string, will be different. For example, from 1 to 9, once will be like this, second time like that, and so on. Random, and that's cool, that's strong. We want that. But if you are speaking about retrieval data, it's okay. But other operation like aggregation, summing and counting and so on will be hard to get, because how to summarize something that's each time different. So it's an obstacle. There's a solution for that. On the next scenario, encryption will be like this. Each time the same string will be encrypted on the same way. It's faster, it's better. You can use almost any other SQL operation, but it's weaker. So if someone looks on you and sniff your network traffic, maybe in some point in time we'll get the pattern. But also there's another catch. So there's a solution for that. On version 2019 and improved in 2022 is always encrypted with secure enclaves. What it means? It means now the decryption will be now again we are pushing stuff on the server side, but to actually implement this, you need to have specific RAM modules inside your servers, and SQL Server will use rotating keys. So it means the key will change almost very frequently. So each couple of minutes you have different key that actually rotate around the data to actually do your stuff. So if the admin get the one key, it's not possible to actually get each time different key, because it's so far as I know, and I didn't find any research that anyone actually penetrate. It's always encrypted and secure enclaves. And now this post-breach cryptography. So if your database goes out, the best way to protect your data is that sometime in the past we actually activated TDA. TDA is protection of your data, that actually the entire database is encrypted. So SQL Server itself will do encryption and decryption. So there's the key hierarchy. So there's the SM key, DM key, and so on. So if someone pulls out entire database with only just one key, it will be useless. Really good feature. So this feature is by default, I believe, now in Azure. And backup encryption. If in some business scenario you only need to encrypt, or you only need to encrypt just backups, you can use this. So it's just TDA, but on the backup level, and better than nothing. So if you don't have the money, and there's a whole bunch of reasons that actually you don't want to use this TDA and backup encryption, you can use something from this 7-zip, Windra, or another tool, because 7-zip is open source. It's free, and by default, you can when you activate encryption of your 7-zip archive, it will be AES-256. So you get the military-ready encryption for zero money. So there is not actually justification from your and my side why you will not use encryption to protect your database and backup database files. Okay, now I will try. I don't have time to actually show you all these videos. I believe this presentation will be publicly available after this conference. I will give you access to all these videos, but I will just now show you some of them. Please just give me a couple of minutes. Okay, let's show you this.
Jasmin, can I please interrupt you? We promised, yes, of course, at least 5 minutes for Q&A session. So maybe it'd be a good idea just to link to the videos and give people opportunity to ask questions, if you don't mind.
Okay, Irfan, thank you very much. Can I just show you this video about
sure?
So
sure.
Okay, thank you very much. So just tell me, do you see this video on the screen?
Yes.
I changed. Okay.
Yeah.
So I will be the narrator of this video. So I will now create some sample database and create database encryption key. And if I type select on the sys view to actually see this key is a master database of this custom database. So for the sake of the demo, I will create some sampled table, encrypted customers with some attributes. Doesn't matter, just to show you this information. And now I will create certificate. So now I'm creating 2 layers of decryption inside this table. So a DM key, certificate, and asymmetric key itself. And you will see now how can I encrypt this data. Okay. And don't forget, always you need to open and close the key after usage, because if key stays in memory and the Windows falls down, dump of the memory actually expose that key. So be aware of that. So just for sake of demo, I will now import the data from a sample database, some customers, to simulate the real data. So you'll see insert into my new table, and you will see down below there is an encryption part, and here it is. So encrypt by key. So you see, so it's a SQL statement. So it's built-in. Key GUID, name of the key, and name of the column actually are encrypted. So simple as that. And this is the laptop. So now I will show you that even on 20,000 records, it's screaming fast. So there is no justification that encryption is slow. You see, 3 seconds on my laptop is actually without caching. So if I want to see those data now, I will close the key, of course. You will do actually all do this stuff inside your environment automatically, of course, not by hand. And now select from encrypted customer, and that's it. So you see last name, and I will need to scroll because there's no values, and you will see credit card, expiry month, you see they're also encrypted. So that's it. I will stop here. Just back to my presentation to finish this. So also you can, if you want to learn more about encryption, you can use official Microsoft resource. Also, you can find my book, just to say this, my book about SQL Server Encryption on GitHub. It's free of use, and a couple of articles. Actually, I write about SQL check. And just keep calm while we steal your data, and you are cool. Questions? Thank you.
I will be very quick with the questions so we don't hog too much time. And I'm sorry if not all of them get answered. And the most important one, what can we do if we use the Ashley Madison dating services and pay the premium to delete our profiles? I'm asking for a friend, you know.
You're asking for a friend. Okay, if your friend actually used Ashley Madison before a couple of years ago, actually he can take the lawsuit to actually get the money. He get a lot of money for that. To be honest with you,
I think he's more interested in protecting his privacy from his wife, but I'm not sure. I must ask him.
But if you are speaking about that, unfortunately, there's no privacy anymore. So okay. Those databases are outside. So, and to be honest with you, there's a people even from this area, regional ex-EU countries and so on. You can, if someone has those databases, you can find anything inside.
Okay. Now, jokes aside, this looks like the most interesting question to me. So I'll start with this one. If we generate the DM key on let's say on-prem, and encrypt the DB, and for whatever reason we decided to physically move the DB to another system, whether as a part of some sort of disaster recovery procedure or hardware upgrade or transfer to the cloud or whatever, will that transfer render the DB useless, considering the SM key will be different on the new system?
Yes, it will be useless. So in that case of scenario, you will need to actually to create the backup of the master database of SQL Server itself, to restore it there, to have actually those case. Then after that, actually restore your custom database. So the most efficient way is actually to decipher those data, move it to next environment, then encrypt again.
Okay, Katja, before I continue, can we have 2 more minutes just to cover 2 more questions? Okay, thank you. We have another question in the question and answer box. It says SQL query with encryption is only for equality. Will it work for contains query or like?
If you are speaking about always encrypted, about that feature, the like feature will work on the matter if you use deterministic encryption. So it's same every time. But if you're speaking also about secure enclaves, so it's actually by default you can use any SQL feature that you actually want to use. But on the randomized part, simply not possible.
Okay. So to a similar note, if we use always encrypted, for example, we have the private customer information like first name encrypted and so on, and we want to count all the Jasmins in the DB. Does that mean the DB engine will have to decrypt all the rows, even if it's a telco system and it has 15 million records, and then count them in memory?
Of course. So because there is no way actually to know without the decryption. So okay, if you say give me count of all Jasmin, so he actually needs to know what encryption string is Jasmin. And he actually decide that he can actually just count all of them and say you have 50 Jasmins. But so that's a small downside of the encryption, because if you use a heavy operation like and so on, simply you have to decide are you going to use that strong enough, or you actually put the level may below.
Okay, and when we do query the encrypted database, is decryption implicit, or do we have to explicitly decrypt columns that we want to either match or do any sort of operations on?
Each time, only if you use TDE is always by default. But if you're using a column encryption and always on, you actually you have to say I want to decrypt this information or encrypt. So there is no way to actually SQL Server knows my intention on this level.
And although I have maybe 5 or 6 more questions, I will end with this one. And this one is somewhat unrelated to a specific topic, but it is something that I heard before people are curious about. And it is on the topic of cryptography. Why are key lengths for symmetric algorithms usually much shorter than for asymmetric, considering asymmetric by design are more secure?
Okay, that's the math part. Okay, on asymmetric, so basically AS256 and RSA 4096 are the same on the level of protection. So RSA is actually built on the factorization on very large prime numbers. In a nutshell, so you find the really big you find a really big prime number, first and second, multiply them, and you will get the key. So the brute forcing means you have the output. The brute force means I have to decide. You have to find which 2 numbers actually create this output. So it's a really difficult math operation. But from the AS part, they are using totally different approach. For encryption, linear algebra, S boxes, M boxes, S boxes. So again, it's kind of dry topics, but the output of the AES and the ARS are on that level almost the same. So the key length from RSA doesn't mean it's better from AS and vice versa. So basically, it's a by nature of the algorithm itself.
Okay, thank you. Unsurprisingly, this topic stirred a lot of interest, and unfortunately, we cannot go through all of it. I promise this is going to be the last question. So we need to move forward with our lecture schedule. So I just want to thank all of you for the attendance. I'm glad to see 130 something people was interested in this topic. Thank you for interesting questions, and above all, I want to thank Jasmin once again for his informative lesson to us. And now I would sign off and just say goodbye to everyone and ask Katja to take it over and lead us into the next session.
Yeah, thank you all of you, Jasmin, Roger, and out.